Completing this project took a ridiculous amount of time and effort. It took months to get here, but we did it. One thing is for sure. In the world of development, you're never really done. There's always room for continuous improvement. Each script has evolved as I was making this video series. Now, there's a few remaining things I wanted to show about the setup. Let's check in on our Proxmox host. We set up a Proxmox instance of 300 gig of disk space, but only 200 of that was usable in our local LVM. Now, with 9 VMs, Kubernetes, Rancher, and the persistent Nextcloud deployment, we're using about 150 gig with all the VMs using the thin local provisioned LVM. We can also see all of their disks listed here. I faced many challenges during this project. In earlier takes of the video series, the VMs would have enough resources to get Kubernetes deployed, but I wouldn't have enough disk space or RAM to successfully deploy the components. Through trial and error, I eventually got adequate parameters which I had to define in script 2b. Additionally, another problem I ran into is CPU cores, especially CPU cores on the host. The underlying physical server that runs everything is actually VMware, and this has 24 cores, but it also has other VMs running on it. So I assigned the nested Proxmox hypervisor 8 CPU cores when I started this project. But if you add up all CPU cores here, or all 9 of them, that actually totals up to 22 cores needed in total. We can also see that listed in the hardware here on each one of the VMs. What that means is the VM's processor cores have to wait until some of the Proxmox host's 8 cores are available. What I learned from this is deploying pods in Kubernetes has a lot to do with timing of dependencies. I especially learned this in script 6. If the MariaDB pod was not yet ready, the Nextcloud instance couldn't connect to it. I had to build a set of try-catch and retry attempts to get the script to reliably deploy everything. This problem became even worse when in one of the video takes, I accidentally started out with the Proxmox host only having 4 cores instead of 8. That really put the pressure on those 4 cores, and the VMs had to wait in line for the processes to complete. But on the bright side, it really brought to light what the dependencies were. Not only did one pod have to be ready for the other, but certain components of individual pods had to be initiated before proceeding to next steps. There were several potential points of failure I had to work around. Even after the pod showed a ready status, the Nextcloud pod had to first have certain files in the pod created before attempting a connection to the MySQL database. Additionally, when only running 4 CPU cores in the Proxmox host, a connection attempt could actually cause the MariaDB pod to crash because it lacked resources. But I built in another series of try-catch and retry attempts here as well to make it more reliable. Again, this really brought to light what dependencies were there. We can even redeploy script 6 using only 4 host cores to showcase this. In order to do this, first we need to shut down our VMs. I'll exit out of our admin VM. Now we're back as Ubuntu Prox, and I can go back to script 2c and get the code block to gracefully shut down our VMs. I'll copy that, then I can paste that here. Now, gracefully shutting down all our VMs may take a while. Wait for all of these play buttons to go away. So now our VMs are all shut down, and now we can actually shut down our Proxmox host. With our Proxmox host shut down, I can now edit it and change it from 8 to 4 CPU cores. Now we'll power it back on. Okay, so our Proxmox host is back up. I logged in as Ubuntu Prox. Now I can run script 2c again to start all the VMs. With all the VMs powered back on, I should be able to log back into our admin VM. Now, I can either SSH to it or run script 2D. I will run script 2D and skip the VM updates, and it SSH'd into the admin VM. Now I can type in ls, and let's see if I can open up another tab of Rancher and log into it. I don't think Rancher is up yet. So Rancher isn't up yet, and our Nextcloud instance isn't up yet. Both are still in an unknown status, so it doesn't even know if they're running yet. kubectl get pods -- all namespaces. Now we can see that Rancher is running, just not yet ready. Okay, so we finally have Rancher started, and we can see that its CPU is crying. It is struggling here. We're in the red, and it's struggling to redeploy things. If I was to go back here and say, show me the pods for Nextcloud, the good news is they're both running. Okay, and all of our Rancher pods are running as well. So therefore I should be able to hit refresh here and see that come up shortly. Okay, so Nextcloud came back. So it's there, it just took a long time for it to come back. And we can see it coming down now that things are starting. These are previous errors from it timing out. And it does actually look like everything that needs to be running is running. The next thing I wanted to show is redeploying script 6 with reduced CPU cores. Initially when recording, I couldn't reproduce the same scenario in which things would consistently fail deployment and require the fail-safe components of script 6 I discussed earlier. To better showcase what I was describing, I then took things to the extreme and reduced all VMs to 1 core each and made the Proxmox host only have 2 cores total. With an extreme bottleneck, I could show things retrying, but the other issue was that Kubernetes would barely run at all. Things were extremely slow at this point. To have a chance at showing the deployment in process, I restarted all my nodes with 1 core each and gave it overnight to let all Kubernetes components start. By the next morning, after I could see everything was running again, I tried redeploying script 6 and we could see some of the failsafes I added in action. But due to how long it takes to deploy, when Kubernetes barely runs with these limitations, I can't show complete end-to-end run-through, but here's a couple highlights. The first big failsafe is the MariaDB deployment and customization of the Nextcloud Database Edition. We can see it trying to grant privileges, fail, and then retry until it succeeds. Another failsafe is a section when the script attempts to connect the Nextcloud instance to the MariaDB database. If for some reason the MariaDB pod crashes during that connection, weird errors like this one start appearing. The connection gets refused and we see there's a few additional retry attempts here. Then we eventually get to a point where the script gets a message from the connection attempt stating the maintenance install is not defined. This signals that there is a corrupt deployment where the database is no longer accepting new installs, but there is no Nextcloud deployment. At this point, this deployment needs to be terminated and a new one is rolled out. We see a new namespace is created and essentially the script restarts. After the script restart, it does take quite a bit of time to deploy. I fast forwarded here, but this quickly shows that the script does run end-to-end and complete. We can then see me logging into Nextcloud here. Okay, so moving on, another thing I wanted to show is manually logging into a pod. kubectl get pods -n and Nextcloud. Well, we see the same output that's up here. So we have these 2 pods that are running. Now, if I was to copy and paste a command that I stole from script 6, it basically gets the name of our Nextcloud pod into a variable called pod name. Echo pod name, and we have our pod name right there. So kube control exec is a way to go and log into a pod. And now we're logged in as this pod with the username root. So it's almost like we SSH'd into a new VM, but at this point, this is a pod. but it is its own environment. So I can type in ls and see the things that are within this pod. I can say cd config and then ls, and then I can type in cat config.php, and this is the config file that we had from up here. Pretty cool. And in script 6, to actually modify the config file, it runs kubectl exec and then runs a few other things within that, such as other commands like sed to replace text. And that's how we got our trusted domain in here. But this is a good segue to talk about access level. When deploying things in a bash scripted method, I have the ability to run kubectl exec. But in many environments, we may not have the node or VM level access to be able to run kubectl exec. And that's where something like GitOps would come in. We'll have to deploy things in a completely different manner, since our access level will be different. And so how it's built will have to be a different approach. In the next section, we'll explore this different approach using GitOps to send deployments to Rancher instead of deploying directly in our shell.